We'll be doing Prairie Mass League round number 116. The most requested one is question 5, which is the one I will be doing. So this is question 5. Let's read the question. So x is equal to the square root of 10 plus the square root of 1 plus the 10 plus the square plus the square root of 10 plus the square root of 2 plus the square root of 10 plus the square root of 3 until the square root of 10 plus the square root of 99 divided by the square root of 10 minus the square root of 1 plus the square root of 10 minus square root of 2 until the square root of 10 minus the square root of 99, as you can see on the screen. But I will show you how you can get exactly what x is. Okay, so it's asking you what is x basically. Because if you know what x is, you're going to know what x squared is. So the question is really, what is x? Like this part doesn't matter, because if you know what x is, you're going to know what x squared is. The right answer is B, by the way, in case you're wondering. And so you can check your work if you want to try to solve it like now. You can, okay. If you're not sure how to solve it, I'll show you how. So personally, I solved this question by doing this. Disclosure, this is not a good method, and it's not a method that you should use. But it is the easiest one, so. I basically will just look at patterns of what if this is not 10 and 99. So 99 is equal to 10 squared minus 1, because 10 squared, that's 100. And then minus 1, you'll get 99. So instead of writing 99 here, let's just write 10 squared minus 1. The square root of 10 squared minus 1. So I was thinking to myself, what if, okay, so instead of 99, here we also write 10 squared minus 1. Instead of having 10 here, what if I replace all the 10s with 2s? So if I replace the 10 here with a 2, then let's see what will happen. Then this would be 2 squared minus 1. So that would be the square root of 3. And this would also be 2 squared minus 1, which is the square root of 3. And what would x be equal to if 10s are replaced with 2s? So let's take a look. I just put it in the calculator. Okay, so if we replace 10 with 2, we will get this number over here. 2.41421. And then instead of writing 10, we replace all the 10s with 3s. We will also get 2.41421. And I know that this number is just 1 plus the square root of 2. So the pattern is suggesting that it doesn't matter what number this is. As long as it's some number plus the square root of 1, the square root of some number plus the square root of 1, and if you keep adding until the square root of that number plus the square root of that number squared minus 1, divide by its counterpart, you will always get 1 plus the square root of 2 for x. And if you figure out x, you know what x squared is, and you know what a and b and c is. So that's the way I did it. But however, this is not very rigorous, because the thing about pattern is if you don't have a proof why the pattern will continue, you don't actually know that the pattern will continue. Because what if I replace I don't know, let's say the 10 was 4. How do you know that you will still get the same number? So I will be trying to prove it more rigorously. Okay? Because if I just end the video here, Steven will fire me. That's another reason. But anyways. Okay, so I'll be proving that. So the way to do this problem, like at least like the way that it's intended, is something like this. So you have x is equal to, I don't know, I'll just call everything on the numerator a divided by b. And you're trying to figure out what x is, which we know is 1 plus the square root of 2. But assume you don't know that. Well, or assume you want to prove that, let's say, because it's easier to follow, just for the video purpose. It's easier to follow if you already know. Like, follow along for the viewers. What you want to do here is, instead of trying to prove why this is true, you put b over here times, you basically multiply by b on both sides. And you want to try to prove that these two things are the same. But how are we going to do that? You gotta assume two things here. The first assumption you should make is the square root of 10 plus the square root of, let's just say a random number n. A random number n plus the square root of 10 plus, again, the n is just a random number. That's between 1 and 100. Wait, no, that's between 1 and 99. You have to like assume this identity is true. I'll show you why you should make this assumption later. Okay, 10 minus the square root of 100 minus n. So I'll show you why you should assume this way. So this is a question, which means that it is designed in a way where everything cancels out. So everything is going to cancel out. Which is why you should assume that this is true. Let's first, let's talk about like other properties before this assumption. So as we said, we know that x is equal to a divided by b. So x times b is equal to a, right? So let's just like write a and b out, so it's more obvious why you want to assume this is true. So we have x here multiplied by the square root of 10 minus the square root of 1 plus the square root of 10 minus the square root of 2. Now, notice that this is just b. The b is just the thing in the denominator. Well, I shouldn't use b because b have a value. But anyways, so this is just the denominator. We're just multiplying the denominator on both sides. You keep adding until the square root of 10 minus the square root of 99. And then on this side, we have the square root of 10 plus the square root of 1 plus the square root of 10 plus the square root of 2 until the square root of 10 plus the square root of 99. What we're trying to do here is we're saying that for any number n, so let's say n is 1 for just as an example, okay? Let's say n is equal to 1. So this term here, because 10, oh wait, that's this term here. 10 plus the square root of 1, because n is 1. We're saying that this term here plus the last term here, so let me draw this. the sum of these two things is equal to x, this x here, multiplied by the square root of 10 minus the square root of n. That's this term here. And plus the square root of 10 minus the square root of 100 minus n. That's going to be this term here. So what this is saying is the sum of these two things is equal to x multiplied the sum of these two things. You can, so hopefully now you see why this assumption is helpful. It is helpful because then everything cancels out as the question, like, because the question is designed this way, which is yeah, why. But anyways, so this thing, the sum of these two things multiplied by x, and the sum of these two things multiplied by x is equal to the sum of these two things. So, it's equal to the sum of these two things. So you can see how everything cancels out. Let's say n is 2. Then this and this, okay, so this and the square root of 10 minus 98, the square root of 98. These two things would cancel out with this term and the term before the last term. And for square root of 3, square root of 3 and square root of 97 will cancel out with the square root of 3 and the square root of 97 here. So almost everything will cancel out if this is true, which I will prove this is true later. This will be the last part of the video. So for now, let's just assume that this is true. Notice not everything is going to cancel out. Why? Because there is 99 terms. 99 is an odd number. So you're going to have something left after the 99 terms. Got canceled out. So let me just, this is term 1. Let's just write T1. And then there's a bunch of other term in the middle and then term 99. And on the other hand, you have term, I don't want to use the same letter. Let's just do term 1 prime to the last term. What you're going to be left with is the 50th term of the right hand one and the 50th term of the left hand. I'll show you exactly why. So let's say you have 3 terms here. This term, and this term, and this term, and this term, and this term on the right hand side. What we're assuming is that like these two things would cancel out with these two things. Notice there's something left in the middle. And how are we going to calculate that this term in the middle is number 50? Well, you can see 1 plus 99, that's 100. 2 plus 98, that's 100, right? Because we're adding them this way. So 49 plus 51, that's 100. 50 doesn't have a pair, right? Oh, wait, I used something different. But anyways, 50 doesn't have a pair because 49 and 51 are a pair. 50 are left there alone. Okay. Okay. So 50 is alone, which is exactly how we're going to figure this question out. So we have x multiplied by, again, on the right-hand side, everything got canceled out other than the 50th term because it's left in the middle. The 49th and the 51st also added up to 100, like 1 plus 99. So this is the only term left. And on the other hand, this is the only term left. So we know that x is equal to the square root of 10 plus the square root of 50 over the square root of 10 minus the square root of 50, right? And I'm just going to tell you x is equal to, I'm just going to tell you that x is equal to 1 plus the square root of 2, like we did before. And I'll show you exactly why. If you were to just put this number in your calculator, this is what you will get. Okay, I'll show you. 10 plus the square root of 50 and 10 minus square root of 50 is equal to x, which is equal to this number. And notice, this number is just 1 plus the square root of 2. So that's how you can figure out what x is on your own without putting like a billion numbers into your calculator. But we are still not done. We're still not done. Because by looking at this number and saying that it is the same as 1 plus the square root of 2, that is not very rigorous. What if this number is 1 plus the square root of 2 plus 0.0000001? Then you will still get this number. So how do we like rigorously prove that this is equal to this number? And another thing that we kind of forgotten is, why is our assumption true? Like, we can't just assume something and hopefully it's true. We need to also prove it. So I'm going to prove why x is equal to 1 plus the square root of 2 first. And then I'll prove our assumption, which is basically this, but like a lot more complicated. So you really want to make sure you understand what I did here, or else you probably won't understand the other proof. So let's just first assume x is 1 plus the square root of 2. That is equal to, instead of writing square root of something over square root of something, I'm just going to put a big square root over here. 10 minus the square root of, this 10 plus the square root of 50. And 10 minus the square root of 50. That's square root of both sides. 3 plus 2 times square root of 2. Which is the answer. This is A and this is B and this is C.